Longitudinal waves are waves in which the displacement of the medium is in the same direction as, or the opposite direction to, the direction of propagation of the wave. The other main type of wave is the transverse wave, in which the displacements of the medium are at right angles to the direction of propagation. These are the two textual definition of two types of waves. I hope we've read this definition before. Today in this video, I'm going to explain about these definitions' actual meaning, and you'll start to feel the wave's energy movements. So stay tuned. Waves can move one place to another through a media. For example, water waves. If you threw a stone into a pond, then water waves will be created. The media of this type of wave is water. Like water waves, there are many types of waves contained in this world. There are two types of motion for waves, one is longitudinal, another one is transverse. First, consider longitudinal waves. You will get a visualization of longitudinal wave after hearing this explanation. So get ready for that. Suppose, consider a media which is compressible. Now in this media, when some energy generates, it compresses the media in front of him. Like a pillow, if you use your energy to it, it will get compress. Now suppose some energy generates in this media and, as I said earlier, in front of this media will get compress. So what happens when this energy moves forward from first molecule to last molecules of the media? Just take a look. Something like this will happen. So here we can see the energy travels one point to another point by the compression and expansion effects of the media. So, it generate a waves as we see a little bit earlier. In this energy movement, the particles or molecules of waves are parallel to the motion. Because as the energy moves from left to right, as well as the molecules also moves in left and right direction, there is no movement of the molecules to the upper or lower direction. So, longitudinal waves generates this types of movement to pass energy from one point to another. Sound wave is the example of this type of waves. Let's have a look. See how sound waves pass its energy. An analogy of this type of waves can be described. Do you remember about a playing toys named dominoes? It's an amazing tools to pass leisure time. I remember, we'll organize this dominoes one after another as long as possible. Then we pushed one dominoes down and then magic happened. After a few seconds, we found all dominoes laid at the ground. So our fingers' force was provided to the last dominoes by some mutual effect. Whenever I remember my childhood, always fascinates me. However, similar things happen to the sound waves or other longitudinal waves. I hope you can grasp this analogy. While the child are organizing the dominoes, something furious maybe happened. We're not accountable for that. So now, let's move to the another type. Transverse wave. Suppose the media this time is not compressible, and the energy again generates as before. Now what will happen? Can you guess? The molecules try to tear up the media to move forward, but it can't. So, the energy gained molecules jump up and try to provide energy to the second molecules. And then the remaining molecules do the same. So something like this happen. Watch this movement closely. See what happens. So in this process energy moves left to right by creating the molecules movement up and down. Or, you can say, molecules moves transverse to the motion of the energy. Light waves is a good example of this type of wave. An analogy of this type of movement can be a lace movement. If you hold a lace and put a swinging force in it, something like that will happen. So your hand force will move towards is to end of the lace. So, longitudinal dissimilar, and again a warning. Don't do this experiment with red color lace while you are in front of a ball. You may get a tough day with the ball. Okay, that's all for today. Goodbye. Hasta la vista.